Water keeps us from going into a dry wasteland climate. So what does it do for us? Well, we drink water. Water falls from the sky and it keeps our crop seasons plentiful so that we can eat. However, sometimes it doesn't rain. The land gets dry and we can't grow crops, we can't drink. What would this cause? If our food production went down and we couldn't drink, we would go into a state of panic with a shortage of food, and that's called a drought. A drought is nothing more than a prolonged period of no rain. Recent ones have been in Australia. It was called the Millennium Drought. It was 14 years. There was one in northern India, in China, California, Syria. My experience, I live in western New York, which is a land just covered in fields, cornfields, any kind of fields. And last summer, we didn't have enough rain to have a super plentiful harvest. I've done some research, and the side effects of a drought can get pretty scary. Droughts can bring pain, despair, as a result of starvation, and then can eventually lead to death in some parts of the world. So we need another way to get a surefire water supply. Today I'll discuss the impacts of a drought and some recent examples, and a notable solution that we should look into. Because everybody's different, socioeconomic status is different all around the world. They deal with droughts differently. So when a drought occurs, water leaves the surface of the earth through evaporation or use. In China, they overused their water and they're running dry on water. So some different forms of what the ground can look like when a drought is there or continues to be there is the land gets really hard. It gets pretty solid. Sometimes it cracks, and then eventually it can turn into deserts, like the Sahara Desert in Egypt, in Africa. So the droughts, they impact not only us, what we eat, but it impacts our finances and productivity. Charles Iceland, he's the aqueduct director of World Resources Institute, and an aqueduct director maps out water resources around the world to see where there's droughts and where there's a lot of water. And in his article, A Global Tour of 7 Recent Droughts, from 1995 to 2009, Australia's supply went down with production and industry. The farms suffered, and the small businesses that were tied to the land also suffered. Charles Iceland goes on to say that Australia tried many solutions. Some had no effect, and the solutions that they tried were only short-term to prolong their water supply so that they can keep going for just a little while longer. And the government gave farmers and small businesses $4.5 billion to help them keep going. So in a recap, droughts cost money. So an article on Science Direct called Sustainable Irrigation: How did irrigated agriculture in Australia, Murray-Darling Basin, adapt in Millennium Drought? And they did exactly that. They tried prolonging it. And prolonging their methods were crop mix changes. They tried trading water, and they tried improving their technology. These would work, but with crop mix changes, you want to make sure that you have water so that the crops can grow. And with water trading, you want to make sure that you have water so that you can do so. And if you have no water, you can't engage in those activities anymore. So with those who succeeded, it was only short term. So think about this. All of our water, plants die, our food production, our food source goes down. Our population rate is actually increasing. It's been increasing for a long time. So we need more food in the future, not less. And droughts bring less food for us. So yes, we wouldn't have enough food or water for ourselves, and also the animals that we often eat need the food and water as well. So Charles Iceland goes on to say that it would plunge the world into crisis and chaos. It would be like an epidemic, except without the virus. So the only way to stop this, we need a long-term solution to make sure that we have enough water all the time. And so a drought's effect is seen on land. 3% of the world's water resides on land, on the continents. And when that's gone, we have to think, what do we have left? Well, we have 97% of the world's water left, and that resides in the oceans around the continents. But in this 97% of the water left, it's all seawater, which means it's salinated water. It contains a lot of salt. And we can't use this. We can't drink this. If we were to drink this, it would dehydrate us rather than hydrate us. So in a source, one of my sources was an article named "How Much Salt is in the Ocean?" And it was in the 14th issue of Science World magazine. And they said that 35 kilograms of salt reside in 1 kiloliter of water. So it's a higher concentration of salt in water, which would, again, dehydrate us instead of hydrate us. And we would be better off actually not drinking water rather than drinking salt water. So, how do we make this water usable? It's through a process called desalination. It removes the minerals and salts from the water and the bacteria from the water, and it allows us to reap the fresh water out of it and use it. So this technique has been used since ancient times aboard the ships on the ocean. In a source from the USGS Water Science School, they told us that aboard their ships, that when they were sailing across the ocean, they would drop buckets into the water, bring the water back up, and they would run it through the desalination process and have fresh water aboard the boat on the go. And desalination eliminates the widest range of contaminants. Contaminants being any of the minerals inside, in this case salt, and also the bacteria. We can also see desalination in nature, in something called the water cycle. So you have the ocean, and the sun hits the water evaporates into a form of vapor. It rises into the air, and it eventually hits colder air, and that colder air makes the vapor into a liquid again, and you have rain, which goes to run off into the mountains, and then from the mountains it goes back into the lake or the ocean. So, like ships, you can do this on a personal level. You can make your own, or you can do it more large scale for a larger population. So it's affordable. It can be handcrafted, but on a larger scale, it's really expensive. You need the material to make the storage containers to store all that water. You need the chemicals to dump into them on a regular basis so that the bacteria and the mold doesn't stay in there. You need the electricity and the source of heat to keep the heat going. And then you have to find means of getting all that seawater to where you want to be. So, according again to the USGS, the United States use it for California and neighboring states because of their arid climate. But they don't do it too often because it is very expensive. So they do this, they desalinate most in Africa. They are in the desert climate but their whole continent is surrounded by ocean, by seawater. So the countries that do this the most in Africa are Saudi Arabia, Kuwait, the United Arab Emirates, Qatar, and Bahrain. So who experiences drought more than Africa? So it could fit into your daily household life, just like a coffee pot. The basic process is you need heat, a container with the salt water that you want to use, and you put that above the heat. Get it to a boil so that it starts vaporing. The vapor will rise into the air, and then you need some sort of cool water, container with cool water, above it. And what this will do is when the vapor hits it, it'll turn it into fresh water. So fresh water will be on the bottom. And then if you find some means, however you want to do it, to drain it into a cup, then what would be in this cup would be fresh water that you can just drink. So all it needs is it needs building. It needs a creative mind to build it. So we've looked at the real life problems, the recent droughts that we've experienced in recent times, how it affects us. It affects us financially, productively. It affects us. So we can't rely on the short term anymore. We can still use the short term methods to prolong our water supply, but it's not reliable. We need something more. It can cost nothing. It can cost a lot. It just depends on how big you want your desalination process to be and how big of a population you want to use it for. Is it just for you? Is it just for you and your family? Is it for a large population? But we can look at all the costs. We can look at the statistics. But all in all, we're talking about people. People need water. They need to live. They need to survive. And some right now need it more than most. So let's start talking about desalination as a means of providing them that water.